Okay, there's just one last thing I wanted to mention before we kick off with the questions, and just noticed that in the textbook. So, in my derivation for looking how the shear force varies, and I mentioned that this is going to be where you're going to get maximum shear force at the middle there. And here we will get, because we're attached to the outer side, and the outer side is nothing there, so therefore we'd get a 0 there. And I described that the average, if you sort of like an average value of this, you ended up with, say, 2/3 of maximum. So I called that shear average. Probably not a great notation, because in the textbook you will see, depending on which one you're using, shear average described as what are we doing? VQIT. So what they mean by average there is they're not referring to my average. So I'm talking about the average of this actual profile. What they're saying is that when we are looking at some sort of, maybe something a bit more complicated like an I-beam, I can tell you what the shear stress is going to be across that width, okay, T, and across that width there. So that's referring to the average shear stress across the width. That's what that notation is about. Now obviously that is going to vary if you go through something like an I-beam. So we'd expect this to suddenly shoot up when we're going to go into the middle bit. And that's because we're not taking into account, so while we're using this term average here, we're not taking into account we've actually got a discontinuity here, which is going to make, probably I would imagine, your shear stress go crazy at that sharp point. So that's just a little technical note before we move on to do the solutions. And when you look up the solutions in the book, I didn't want you to get confused between this term here, average, and what I was talking about in terms of the average value for your profile.